If you are fairly or completely new to DataWeave, this might be a little bit overwhelming for you at first sight. So let's go through it little by little. At the beginning of the script, an array of 10 elements will be created, so this is the place where the size of the mocking data set is determined and can easily be adjusted. Each array element will be mapped to an object of randomly generated order data. This is like a loop that runs on a random data generator with the array representing the number of iterations. The random data generation in our case, which will be executed separately for each iteration, starts with two variables named order created timestamp and order state. The first one is defined as a random timestamp, which is generated by random values for the temporal components such as year, hour, and seconds, and concatenating them. The second one is defined by mapping a random number ranging from 0 to 3 to a constant string value. You might ask yourself why these components of the order are created as variables. The reason, as you will see, is that the timestamp of the order creation and the order state are both relevant in several places of the order. In general, variables are defined for structuring or reuse purposes in DataWeave. Now, if you take a look at the following part of the script, you should easily recognize the structure of the order data as you have seen it in the request body example in Exchange we have used for the functional API test. All elements of the order are created by means of random numbers, constant string values, and concatenation, whereas for the order positions, the same method is applied as it is for the overall dataset, as the order position is defined as a subarray of the overall order. And in addition, the size of this subarray is also determined by random. And if you take a look at the timestamp for the last order update, you can see why the order creation timestamp and the order state are also used for the order update timestamp. The order update timestamp is derived from the order creation timestamp by adding a random number of seconds to this timestamp. This maximum number of seconds is equal to 1 week, so we assume that all order updates occur within 1 week after an order has been created. And in addition, the update timestamp is only created if the order state corresponds to any state except the first one, namely in progress. This means that the order creation is not considered as a real update, as no change happened since the order was created, and an additional identical timestamp would be redundant in this case. In summary, the order update timestamp is defined as not just a timestamp that is technically compatible with the required data type, but also as a timestamp that makes logical sense considering the other order information. Okay, so much for the theoretical part of the script. The practical application is fairly simple, as you can just copy the script and paste it either into the script editor of a transform message component, or, as I do it now, into the script editor of the DataWeave playground, which is also included as an external resource of this lecture. As you can see, the result is created very quickly and the dataset size can easily be increased to 100 or even 1000 elements. So let's do that and copy it into the clipboard.